Good.
I love it.
Mentally math!
Let's get mental!
All right. Okay, let's get started.
We haven't seen you in like 2 weeks.
Yep. We had some things recorded from last year, so we haven't been recording the last several lessons.
But
we're back.
We are not mentally math fans. We are back.
Yeah, my catchphrase on those the videos that I have had up there is "Greetings, young mathematicians," but there's no students there, so it's just me talking to myself. Yeah, this is better. Yeah.
Wait, we could really shift because I feel like my desk is in a complete different spot. But I can't.
I'm really joking.
Well, they were like they moved the desks around. If you need to move your desk, they moved the desks around to work on their Spanish projects. So yes, the room has been rearranged and put back together. Yeah, so maybe you ought to move over a little bit, and then move over a little bit. Yeah, anyone else who can't see, just find your spot. It's okay. Okay, that should have given you plenty of time, unless you had been talking instead of getting ready to start. Are you finished?
Yeah, I've already done some of the problems.
Where are they?
I don't write. Should I write?
Yes, you're supposed to write them down.
Oopsies.
What class have you been in all year?
I don't know. Are we supposed to?
Yes, you are supposed to write down at least the answers. Yes. I'm breathing slowly.
Let's hope we don't stop.
Okay. Slow breathing. All right. So here I'm looking at this. These are. Okay, a little stability going on here. These are. Oh, I am not stable here. Two negative numbers, so I know I'll end up with a positive number, so I'll just ignore my negative signs there. And this is essentially asking what is 1/5 of 2 5/10, so that would be 5/10.
No.
Yeah. And then, so here, 3 times 4 is 12, but we're going to keep this in scientific notation. So we'll say 1 2/10 times 10 to the power of, and so since I have divided this by 10, I am going to divide it by 10 one less time over here. So instead of -7, I'm going to say -6. So I'm dividing by 10 6 times instead of 7 times, because I did it over here one time. Okay, now this is interesting. We haven't seen him do this. Really simple though. Combining like terms, so that's really 3y. So divided by 3 is 15. And then, oh boy, more of these. So just going to run through the thought process here and write things down a little bit. So of course, we can think of this as negative 30 degrees Celsius, so we can think of this as 3 sets of -10, and since every degree of Celsius change is the equivalent of 1 8/10 degrees Fahrenheit change, that's really 3 sets of -18. And so adding those up together would be -54. And then the baseline we're starting at, the equivalent of 0 degrees Celsius, is 32. degrees Fahrenheit. So our if we get the difference between negative 54 and positive 32, we end up with negative 22 degrees Fahrenheit.
Wait, you mean the sum, not the difference?
No, the difference. Yes, because basically we are subtracting. I mean, technically we are subtracting 54 from 32, which gets us negative 22. Or we could think of it as just subtract 32 from 54 and slap a negative sign on it. So either way you want to think of it is fine. Okay, so, well, by doing these every day, hopefully you can have it committed to memory how to do these, and you go to any other country on the planet, basically, you can always convert what temperature it is to Fahrenheit, so you kind of know what temperature it is. Yes?
What is sod?
What?
For G, what is sod?
Topsoil. I know, right? Why not just say top? Why not say topsoil? They don't. They don't say how thick the soil is, but it is irrelevant. Okay, so we'll get there in a minute. All right. So, what is 1/3 of $600 is $200, and then what is 1/3 less? As well, 200 minus 600 is 400. Yeah?
It doesn't say to do scientific notation.
Right. Well, yeah, I'd mentioned this before. I'll mention it again. Is I had been operating on the premise that if it's not in the instructions, we don't have to do it, kind of thing. But I did notice that the answer key for the book was doing it in scientific notation, and I think that this is a nice exercise to do. As many times as they throw this at us to kind of get it intuitive, so it feels natural, like the whole thing of converting to scientific notation. So that's why I'm doing it that way. Okay, so if you are buying sod for your yard, topsoil, what will you need to find to determine how much sod you need to cover your yard? The other class figured this out really fast.
This is really hard.
No, it's not. It's one of those things. It's one of those things where it's so simple. It's easy to think that the answer can't be that simple. Then you overthink it.
I'm being sarcastic.
Oh, really? Oh, okay. Sorry, I didn't realize that. Okay, what do you think?
Okay, so answer.
Yeah.
The area?
Yeah, exactly.
I did not know that at all.
The area. So basically, how many square yards are in your yard?
Mr. Referee.
Yeah. What?
I know it's I wrote the area, but realistically, wouldn't you want like a more sod, and not just like enough to fill the area exactly?
You see, that's what I'm talking about, overthinking it. No, please. Therein lies the path of madness. Let's just go for the simplest answer here possible, which is just the area of the yard, so that you know how many square yards of sod you need for your yard.
Nice.
Yeah. Okay. Then this next one is actually more simple than our scientific notation up here at the top. But I guess it does relate a little bit to our lesson today. So the expression of 3 times 10 cubed squared. Now that's weird. 3 times 10 cubed squared. Really just means 3 times 10 cubed times 3 times 10 cubed. So right, that really kind of seems more simple than the one we did above.
I think you might.
Doesn't it?
Someone might.
Anyway, sorry?
Someone might be able to.
Yeah. Well,
because it's in cubed and squared.
Right. Well, it's just times itself, and so it's just 3 times 3, and then just add the 3's together. This seemed harder, to be honest with you.
Really?
Sort of. Anyway, required more. Icky. So today we're talking about powers of negative numbers. Yeah, I might gloss over these a little bit because it's pretty simple. Give us more time to look at these. I will say that the book kind of goes through some convoluted ways of solving these. I guess it's nice to get sort of visual of what we are doing with the monomials in question. So we are doing powers of negative numbers, dividing terms, and square roots of monomials. And yeah, the powers of negative numbers really have nothing to do with the rest of it. But really, they're trying to just get us to remember one basic rule with the negative numbers is when we look at this, regardless of like what the answer is, I mean, do I really need to go like, okay, well, 3 times 4 is 12, and then that's gonna be times -5, so then that's gonna be -60, and then that's gonna be times -2, so then I'm gonna change that to a positive number, turn that to a positive 120, and then I'm gonna times that by a negative number, so I'm gonna have to turn it back into a negative number. Do I really need to go through that whole process, or is there a simple rule I can remember? What's the simple rule I can remember about the negatives where I don't even have to think through about negative, positive, positive, negative, negative, like, and change it back and forth? Oop, oop, oop. Yes, sir.
So if they're like, depending on the number of negative signs you see, if they're an odd number of negative signs, the answer's going to be negative. If there are an even number of negative signs, the answer's going to be positive.
Ta-da! That's the lesson. Have a pom-pom. Yeah, that's really the whole point. So we can look at this and say, okay, there's an odd number of negative signs, so we just know there's a negative. And then I can go 3 times 4 is 12, times 5 is 60, times 2 is 120, times 3 is 360. Boom. Yeah.
Is that just the rule?
That's a rule. I mean, yeah, you can just think of that as a rule. It also is something that, you know, if you don't know the rule and are just going, you know, negative, negative, positive, 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 it will work out, you know.
Fascinating.
Yeah. Okay, so that being said, I'll give you a moment just to do these quickly yourself by writing it down. Okay. And just to say, like, we know we're multiplying by the rule we just heard. We know we're multiplying this an even number of times. So our answer is going to be a positive number. And then, you know, 2 times 2 times 2 times 2 is, in fact, spoiler, 16. Now, it's nice to have this here for clarity sometimes. Like, you know, we sometimes put in parentheses when we're doing things, but do I really need this there?
No.
No, because we just assume if there's nothing there, that it's a positive number. Okay, and then, well, then I can just go over here and go, okay, well, 16 times 2 is 32, and I'm multiplying it an odd number of times. So, dee-dee. And that's all we need for that. Okay. Alright. Woo! Okay, so we're going to do some prime factorization here. If in the process of doing the prime factorization that I'm doing, you're going, hey, wait, there's a way more simple way to do this. Yes, I know, we'll talk about that. And if you would like to just do this in a simple manner yourself, while I prime factorization it out and show you the kind of Saxon method they're going at, you go. Feel free if you want to get the answer first.
Oh wait, we can go ahead?
If you want to like do it, you know, like there's a really much more simple way of doing this than I'm going to do it. So if you would like to just go straight to that, if you can figure it out, then sure, go ahead. Okay, so. But it is a nice sort of mental exercise here to to see what we are doing with the number. So I'm going to do a prime factorization of 12. So that's 2 times 2 times 3. And then I'm going to factor out x cubed is x times x times x. And then we have 1y, so it's times y.
Is this the simple way or
No, this is not the simple way. And then z squared is z times z. Oh, that's terrible. Much better. Okay. And then this is already a prime factorization just by itself. And then I could say x times x. Then times y. Alright, then now I can do some. Can you guess what I'm going to do? Cross-canceling goodness! Yay! So, my 3's can go. My 2 of my x's can cancel each other out. Both my y's can cancel each other out. And there's nothing to do with the z's. Right? So
6 times z.
so now I can what?
He just flushed. He's flushed.
Okay, or you can go next door or something if it matters that much. You can't wait. Alright, whatever. Alright, so we got 2 times 2. That gets us 4. And then we've got this x, so we can bring that down. There's no y. Oops, sorry, probably did. X, and then we've got z times z still, so we can say z squared. Okay, so that's nice, right?
Yeah, that.
However,
Or you could have just.
yeah. However, we could also think of it like this: is
Division is so satisfying.
yeah, I know. Cross-canceling goodness is satisfying, and honestly, in the other class, there were students that preferred to do it by factoring it out. But really, I got a method too here. You could think of this as this.
That's what I did.
Yeah, that's what I did.
Right. That's what I figured some of you would figure out to do. Like the times this.
I'm doing the math.
Z squared
Right.
over 1. Z squared over 1.
You're doing the Mathia method, okay?
Yeah, I learned it.
Times this.
Z squared over 1.
And then yeah, we could just say z squared over 1. Sure. And then looking at this, we can go, oh, well, I mean, these are all just basically division problems, right?
Yeah.
So, 12 divided by 3 is 4. And then remember, if you have exponents but the number is the same for each of them, you just do what with these? Subtract. Thank you. You're totally carrying this here. All right. So then 3 minus 2 is 1, which is just x. This just ends up being times 1, and this just ends up getting brought down. All right. So that's a bit of a kind of quicker, simpler way of looking at it. I mean, you could just look at the problem and do it in your head, I think, if you wanted to. Okay. So how are we feeling about this? You want to give me a 1, 2, or 3? Okay. Yeah. I'll take 2.5.
I'm always.
Okay. All right. We're just getting started here. Okay. Good. I mean, we're basically 2s, 2.5s, 3s. That's fine.
I'm tied.
Your pie? Pie is good. Okay. So that being said, let's try this one. So, do this either way you want. I'm gonna follow the book and do it with factorization. So you can fact, or I could do it both ways
So
again.
in prime factorization, all the numbers you use, they have to be prime numbers?
Yeah. You're trying to get it down to its simplest form. So I'll do it both ways. So I'll give you a minute to figure it out ahead of me. Always take one deep breath and kind of work slowly here. How are you doing? Are you doing it? Did you do it? Okay. Okay, I'll just get going here. I won't take too much time here. Okay, so 2 times 5 times A times A times A. Got 1B. And then C squared. C times C. And then this would just be 2 times 2 times 2 times A, then times B, times B. Like this one, in some ways, bits of it, where you've got a larger exponent on the bottom, it almost makes it kind of a little more intuitive to do the factorization. But okay, so then a little cross-canceling goodness, we can get rid of these 2's. We can get rid of these A's. We can get rid of these B's. We can get rid of these C's. So then that will leave us with...
Actually, for once, I like the Saxon one.
Yeah. For this problem, I think the factorization might work a little better. Well, because it gets a little wonky when your larger exponent is on the bottom. Okay, then times A, so that's A squared. And then you got a C hanging off there on the edge.
I'm pretty sure some math was here. I think this was satisfying.
Yeah.
Yes.
They'd be running it fast.
Yes. Well, I hope he can make it tomorrow for the investigation. That's actually quite satisfying. Okay. Huh?
We gone the whole week.
Oh, okay. Well, too bad. You missed out. Okay. 2 times. Okay, so 2 times 2 is 4. Then we can bring this B down, and that's all that's left here, right? So we got that. Okay, so 4B. Okay, and then the other way you can look at it is 10 over 8. Yeah. Oh yeah. It's far simpler to do.
I don't like getting it all out.
Sure. I completely understand.
Wait, what?
Okay, and then, so we can just reduce that to 5/4. Right here, I'll just stretch myself out here. Improper! Get the fainting couch! Alright, then this is, remember this is an imaginary 1. So just, 3 minus 1 is A squared. And then in this case, sort of 1 minus...
It's 1 over
1 over 2. So essentially, so that's where this is where this starts to get a little strange, and the factorization might feel like it works better, but that basically means this gets canceled out, and
No, that means 1 over B. Because basically square root.
Yeah. And then this is just 2 minus 1, getting us just C with 1, but we don't have to say that. So we just get to there. Okay.
No.
Yeah. All right. So figuring out which ones are perfect squares, right? So a perfect square being, just say as an example, 4 is a perfect square because 2 times 2. There's no decimal involved if you get the square root of it, right?
Yeah.
Right. So that's what they mean by perfect square, for that it just works out perfectly. So it's just asking us here, how can we tell which one is a perfect square?
Are we answering these or?
Oh, we're just picking one out. So I'll say to you, is A a perfect square, and how can you tell it's not?
Well, no, because first of all, 8 is not a perfect.
That's it, and you're done.
Wait, really?
Okay, that's all you need.
Wait, it's C, right?
Huh? It is C. And then for B, while 4 is a perfect square, and this is just x times x, so you can just get the square root of that. We don't know what y is, so I mean, if by some coincidence y equals 4, then it could be a perfect square, but we don't know that. There's no way for us to know that.
Y messed it up.
So yeah,
Why?
why? All right, so
So that's a bit all over that.
oh, thank you. Oh, fist bump. All right. Okay, well, so by process of elimination, we know that it has to be C, but also just looking at it, we can go, okay, well, I mean, we know 36, we can get the square root of that. We know this is x times x, and you can get the square root of that. And then, then here is what we can say is, we can get the square root of the exponent.
Yeah, because y squared plus y squared is at the exponent.
Right, and the only reason why I'm not going into a little bit more of dissecting this is because it is, in fact, our next example. And oh my goodness, there is a very convoluted way of doing this
The way that they did
that I'm going to show you, but really it's just not necessary. But here, let's do this. Oh yeah, we're gonna factor it out. Then we're gonna use a commuted property, and then it's gonna be nuts. You're gonna love this. Okay, so first, yes, we are going to factor the whole thing out. So prime factorization of 36. And by the way, if you want to just get the answer yourself while I'm fiddling around with all of this, please do so. Alright, so we say 2 times 2 times 3 times 3, right? Basically 4 times 9. You can think of it that way. And then times x, those are x squared. And then y to the power of 4 is y times y times y times y. Then I'm going to take the commuted property and I'm going to rearrange these. So we've got 2 times 3 times x times y times y. Oh, I know. Whoa, wait, do you see what we do here? And then times, basically we just did this.
Where did the second row come from? It's 2 times 3 times y times.
I could just say squared, but I'm not, because that's not what the book does. You write it all out again. Oh, don't be sad. It's fun. We're having fun, okay? All right. Okay, and now I can combine my like terms to say that this is 6 times y, 6 times x times y squared times 6 times x times y squared. But if it's 6 times x times y squared times 6 times x times y squared, then I can get the square root just by going goodbye and
Mr. Petrie?
ta-da!
Wait, Mr. Petrie?
Yes.
Can't you just like find the square root of each
You can absolutely just find the square root of each one. Okay. All right. Yes. So let's back up here and try this again. Okay. What's the square root of 36? 6. What? If x squared, then the square root of that is just x. And what's the square root of 4? 2. Ta-da!
Wow, that's
and that is the lesson. Oh, thank you. Okay. All right. So for this, just do the lesson practice for starters.